In this video, I will show you how to use QEMU KVM GPU Passthrough in Ubuntu using VFIO. This method allows you to dedicate a physical GPU to a virtual machine, providing near-native GPU performance within the virtualized environment. This could be extremely useful for gaming or running GPU-intensive applications inside a virtual machine. Before we start with this video, first open the terminal and update your system by running this command. Once it's done, then install Timeshift, a backup tool that allows you to take snapshots of your system. This backup will be used if anything goes wrong with the system. Ensure you backup the entire root system and home directories. Then click on Create to take a snapshot of the current state of Ubuntu. The only prerequisites of this video ensure that your hardware meets the requirements for GPU Passthrough, a multi-core CPU with virtualization support such as Intel VT-X or AMD-V. You can run this command to verify your CPU's virtualization status. Next, you need two GPUs, one for the host and another for the virtual machine. If your computer or laptop running Ubuntu with multiple GPUs, you can allocate one GPU for a virtual machine. For example, I'm using my gaming laptop running Ubuntu 24.04, which has two GPUs, an integrated GPU for the display, and a dedicated Nvidia graphics card. Our goal is to pass the Nvidia GPU through to a Windows 11 virtual machine using the VFIO driver. Now, VFIO stands for Virtual Function I/O, which exposes direct device access to user space in a secure, memory-protected environment. In simple terms, the VFIO driver isolates PCIe devices accessible to virtual machines. It's time to identify the PCIe ID for the Nvidia GPU. Open the terminal and run the following command. Now look for the PCIe ID assigned to the Nvidia GPU, which will appear after the GPU's name in square brackets. Now copy both PCIe IDs of Nvidia VGA controller and audio device and paste them into a text editor separated by a comma. Next, we need to enable the IOMMU feature. Open the grub configuration file and modify a kernel argument. Locate this statement at the beginning of the line inside a double quotes. Type AMD_IOMMU is equals to on if you have an AMD CPU, or replace AMD with Intel if you have an Intel CPU. Then add another argument, IOMMU is equals to PT, which stands for pass-through, followed by VFIO-PCI.IDs, and paste the PCI IDs you copied. Each ID must be separated by a comma. Once it's done, save the changes by pressing Ctrl+O, and exit by pressing Ctrl+X. Now update the grub configuration by running this command. Now it's time to isolate the Nvidia GPU from being accessed by the host OS kernel. To do so, open a terminal and create a VFIO configuration file using this command. Then run this command to make changes to the configuration. Type options space VFIO-PCI space IDs and paste the PCI IDs you want to isolate. Lastly, go ahead and add a line to disable the Nvidia proprietary graphic card drivers from loading during the boot time. Then save the changes with Ctrl+O and exit with Ctrl+X. Now type this command to update init RAM FS. Ensure there are no errors. And that's it, we have successfully isolated Nvidia GPU from the host OS. Then reboot your computer to effect these changes. To verify the isolation of the GPU, run the following command. You should see that the kernel driver in use for both Nvidia GPU and audio device is VFIO-PCI. Now notice that the host OS is using iGPU for graphics and the Nvidia GPU is ready to be passed through to the Windows 11 virtual machine. Now let's proceed to pass the GPU to the Windows 11 or 10 virtual machine. As you can see, I have already set up a Windows 11 VM with the Q35 chipset type and the UEFI firmware. If you need help installing Windows 11 or 10 using QEMU or KVM on Linux, check out the video link in the description for more information. Before adding the GPU to the virtual machine, download the VirtIO Windows drivers from this link. I'm using the stable ISO file. Once downloaded, go back to the Windows 11 virtual machine settings, select the CD-ROM, choose Browse and import VirtIO drivers. Then click Add Hardware and select PCIe host device. Now locate the Nvidia GPU and audio among the available PCIe devices and add them to the virtual machine. Then click on Run to start the VM. Now please remember that the Nvidia GPU won't be detected until we install VirtIO and Nvidia drivers on the Windows virtual machine. To install the VirtIO drivers in the VM, open this PC, locate the mounted ISO, and install VirtIO drivers. After installation, reboot the Windows 11 virtual machine. Now open your web browser and go to the Nvidia website. Download the compatible drivers for your card and install them. Once installed, you will notice the Nvidia graphic card listed in the Task Manager. Now you can adjust the VM screen resolution in the settings. After changing the resolution, you may notice the mouse cursor stops working. To fix this issue, press Window key plus E to open File Explorer using your keyboard. Now use the Tab and arrow keys to navigate through the user interface elements. Then go to the mounted drive and uninstall this driver. Once it's done, reboot your computer and your mouse cursor should function as intended. And that's pretty much it. This is how you can use QEMU or KVM GPU Passthrough in Linux using VFIO. If you have any queries, feel free to post them in the comment section below and I will do my best to help you. Don't forget to check the video description for more information. Thank you so much for watching. This has been KSQRL. I will see you in the next one.